Hello everyone, so I just thought I'd share this cardboard slightly thrown together thing. I put up some pictures of this bit before, this rotor in the middle here, and the two discs that are inside. Point and there, disc that's inside and there, and then I've added this extra bit on top just to act as a sort of frame. And between that rotor and this cardboard disc is also another small cardboard disc either side, so it rotates a little bit more freely. And I put some of these popsicle stick things on here just to stiffen it in particular places. Sorry, I keep going out of frame, that's not very useful. So this is running on a 4mm dowel here through the middle of all of these parts. So as you can see here, I've got 3 layers of cardboard in the rotor part, and this hole there that's the size for Skittles, and a slightly bigger hole there, and a slightly bigger hole here, sort of off centre from the other hole. So depending on which way it was going round, in this case, if it started here and rotated in that direction, it would drop out the bottom within 1/4 of a turn, and if it went the other way it would take 3/4 of a turn to go around. So depending on where you put these holes relative to each other, if there's only one hole in the rotor, you'll end up with a different amount of time between the time that you turn it on and the time that you get something dropping out. But then again, you could have more holes in the rotor so that these all go round and fill up with one Skittle each, and then you end up with a different result. So I was mainly doing this to check that I could do something like this and turn the rotor using a little motor at the back there. So this is upside down. So this is one of these little micro metal geared motors, which I think Mark mentioned in one of his videos. I happen to have some of these because I just got all kinds of bits for different projects that I never got around to. So this has got a ridiculous gear ratio of 1006 to 1. Not sure why 1006. And these particular ones have also got quite a useful feature in that they've got a little shaft coming out the back there as well. You can pop on one of these little things, which is it's got little open bits and closed bits, so you can measure the rotation of the back there and you can get some feedback as to what the motor's doing. But to do that you'd have to have a microcontroller or something similar. And also I've got this mounted at the back here with this little mounting thing, which is just like a little cage which goes over the top and keeps it all snug and sort of solid on there. So at the moment I was just going to see what happens. There's an elastic band that runs around the rotor and there's hot glue on there, so the hot glue is sort of quite tacky, so it grips the elastic band quite well. And out of shot again, it sticks too long on the bottom. And at the moment I've just got it going around that shaft, so that makes it actually a really high ratio between this output shaft on the motor and the rotor, because there's 1000 to 1 gear ratio, but then there's also 3mm to 80mm of the rotor, so that's over 25,000 times reduction. And I got this connected up to a variable voltage output power supply. So if I run this at its nominal voltage of 6 volts, it can run quite a lot lower and maybe slightly higher, but its nominal voltage is 6 volts. Then we get this rotor moving around and the rotor's moving around there. So I'll line this up so you can see that hopefully. So this should turn around and that should turn around there as well. So you can see that moving around there. Now one thing that I note about this is it's quite loud, because this motor's spinning around at great speed and then it's going through all these gears at the bottom. There's a whole gear train there anyway. So that's one thing that I didn't particularly want. I wanted something that would be quite quiet. and unobtrusive, and just sits there and occasionally drops out a sweet for you without interrupting anything else, so I can just get on with other things, and it's otherwise very unobtrusive. So what I'm going to do is just nip off and get a Skittle or two, see what happens here. I return bearing Skittles. So the idea is, I suppose, that this bottom stick's really long. Anyway, so we'd have something like a hopper or a funnel, something sitting on the top there. Skittles would drop into the hole, and then they should drop down into the hole at the bottom. So framed this rather badly. So one Skittle can fit quite nicely in the hole, but if there was another Skittle sitting on top, as this turns, it should only take one of the Skittles away. And I was hoping that that wouldn't get jammed, so it's quite important to get right the depth of that cardboard. It's actually slightly deeper than a Skittle. I went for 3 layers of cardboard, which is slightly deeper than one of these if it's sitting like that in the hole. And so it might be possible to get that jammed. So we need to get the height of that just right and the size of it so that one will fall in and no more than that. And then it should turn round, and when it gets to the point where the hole's exposed on this side, it should throw out a Skittle. And in the meanwhile, imagine we've got some Skittles piled up there because they're sitting inside the funnel, like this. Hopefully again when it comes round we should just get one of those dropping in.